Okay. Alrighty. So to start off today, we are going to think about this idea of you are trying to dissolve sugar into a cup of tea, maybe a cup of coffee if you like coffee more. You want to make it as sweet as possible. Can you dissolve an infinite amount of sugar into your tea? Or is there going to be a limit to how much sugar you can dissolve? Imagine in front of you a cup of tea, 1 cup of tea. What do we think? Anybody? What do we think? You have a cup of tea in front of you. Could you put 40 pounds of sugar in your cup of tea?
For what?
Could you put 40 pounds of sugar in your cup of tea, girl?
I don't know.
Was that a no or an I don't know?
No, it's a no.
Yeah, why not?
Because it's a cup. It's not gonna fit.
Perfect. It's a cup. It's not going to fit. There we go. That is our idea for today. A solubility. Different solutes, meaning different things we're dissolving, they are able to dissolve in different amounts. Okay? Not every single solute can dissolve in the same amount. There is a limit. Oh, my cat's going crazy. Here. There's a limit to how much can dissolve. Harriet, please be quiet.
Casey, check your phone.
Okay.
Okay, there is a limit to the amount, right? You can't add an infinite amount of sugar to a cup of tea. It will all continuously dissolve. Eventually, it's going to stop dissolving. That is the main idea for today. It's called a saturation point. Okay? Girls. A saturation point. This is the main thing you have to know for today. It is the maximum amount of solute that can dissolve. It is that limit, okay? It is that point where you are trying to dissolve stuff and it will stop dissolving because it has hit this maximum amount. All right, this is the main idea for today, so you really need to understand this. Right? You can imagine, let's imagine you have a cup of water and for whatever reason, oh my God, these cats, move. For whatever, Cuddles, stop. For whatever reason, you are trying to stir salt into your water. You can stir and stir and stir and stir and stir, but at some point, you hit a point where it stops dissolving and you've got a little bit of salt stuck at the bottom that just will not dissolve. That would be when you have hit your saturation point. You have dissolved the most and no more can dissolve. Okay, that is the idea of a saturation point. You've reached the limit, no more will dissolve. Cats, stop it. Stop. Oh my God. Okay. Do we have questions about this?
No.
Okay. Thank you, Stephanie. So then we will move on. We can describe all of our solutions in regards to the saturation point, right? We can have solutions that are at the saturation point or not yet at the saturation point. So those are going to be our two ways of describing solutions, okay? We can have a saturated solution. A saturated solution is one. Oh, I'm reading in backwards order. I'm sorry. I got distracted because my cat is now trying to eat this plant in front of me. Oh my God. Okay. An unsaturated solution. Sorry. Unsaturated. This first one on this slide. The prefix un means not, meaning it is unsaturated. It is not at its saturation point. Because it is not at its saturation point, that means that you would be able to dissolve more solute, okay? If you can add in more of your solute and get it to dissolve, then you have an unsaturated solution. The opposite would be a saturated solution. That is one where it is at its saturation point. Okay, oops, what am I doing? It is at its saturation point, which means no more can dissolve because it has reached that maximum. Harriet, I swear. Come on, stop. I'm trying to record this and you're being a brat. The love of everything good and pure. Stop. Whoo, goodness gracious. Sorry, these cats are testing me. All right, so we've got unsaturated, meaning not at the saturation point. Saturated, meaning it is at the saturation point. No more solute is able to be dissolved. We're gonna watch a quick video of somebody else explaining this. Here we go. Not watching this whole thing.
Hi, welcome to a quick tutorial on solutions, unsaturated, saturated, and supersaturated. How do I tell them apart? Here we have an unsaturated solution. Our unsaturated solution is capable of dissolving more solute. You can keep adding solute to this, and it's still got the ability to make that solute dissolve. In an unsaturated solution, all the solute that's in there is dissolved. That means what? That means no chunks, no grit in the bottom. Every single piece of solute in that unsaturated solution is dissolved. Here we have a saturated solution. It cannot dissolve any more solute. But how does a saturated solution look? Well, here's the weird part. In a saturated solution, all the solute is dissolved, which means it looks the same as the saturated, right at the point of saturation. Where the saturated solution is going to look different is when we add more solute to it. If we add more solute to a saturated solution, this will result in undissolved particles. In other words, we'll have chunks in the solution or we'll have grit at the bottom. That's where a saturated solution begins to look different from an unsaturated solution. Okay, so let's check our understanding. Okay, so here's a quick rundown. In an unsaturated solution, it can dissolve more solute. So when you add solute, it doesn't change the appearance up to the point of saturation. It may look cloudy for a while, but if you keep stirring, it's going to all dissolve. In a saturated solution, you cannot dissolve any more solute. Therefore, when you add solute, it's going to change the appearance. You'll see chunks or grit. Now, no matter how long you stir a saturated solution, if you don't change the temperature, those chunks or grit are not going to go away. One more way to tell you've got a saturated solution. You've reached the saturation point.
All right, we're done with that now. Great. Does anybody have any remaining questions? about what is saturated, what is, how do I exit out of this? Oh, gracious. What is saturated, what is unsaturated?
No.
Thank you. Ignore where it says supersaturation. We don't need that yet. Okay. Our next question for today, maybe you've experienced this in life, or you can just think about it in terms of chemistry. Do you think it would be easier to dissolve sugar into hot tea or into iced tea? Does anybody think they have an idea?
I have an idea.
What's your idea, Stephanie?
I think it's gonna be easier to dissolve in hot tea because it's hot.
Okay, good. Has anyone ever tried to dissolve sugar into either iced tea or like iced coffee?
Yeah, it's hard. It takes a while.
Yeah, exactly. It is really difficult to dissolve sugar into a cold liquid, whether it's tea, coffee, whatever. It is way easier to dissolve stuff in hot liquids. That is because of this relationship, okay? Solubility increases as temperature increases. This is what you need to know. Solubility increases as temperature increases, okay? That means that as our temperature increases, it is both easier to dissolve stuff, and we are able to actually dissolve more solute when the temperature is increased, okay? So you are actually able to dissolve more. Meaning that if you had a cup of ice cold water or ice cold coffee or whatever, even if it's the same amount of water as one that is boiling hot, this is going to be my hot one. Okay. Oh, these are such ugly drawings. All right. This one represents boiling hot. This one represents the ice cold. Okay. It's not just a difference of how easy it is to dissolve stuff. You can really dissolve more. So maybe in your ice water, you can dissolve in 6 teaspoons of sugar before it hits that saturation point and nothing else dissolves. But in your hot one, you really might be able to dissolve 24 teaspoons of sugar before it hits that saturation point. Okay? So you can really dissolve more solute based off of the temperature of your liquid. If we were in class in person today, y'all would be testing this out. And it really is surprising how much sugar you can dissolve into water when it's boiling hot. It is really an insane amount, okay? And we are able to graph this. Yay, because it is science, we love graphs. Here we go. So using your ACT graph interpretation skills, you can see this graph. We've got our x-axis is temperature. Our y-axis is solubility. And they define solubility as grams per 100 milliliters of water. So what this is saying is this is how many grams of your solute you can dissolve in for every 100 milliliters of water that you have, okay? And then the important thing to know is that at each temperature, we see this line is going up. Well, this line is telling us how many grams we are able to dissolve. Therefore, our line is the saturation point, okay? The line is showing you the maximum that you can dissolve, the saturation point. So we could read this graph and say, all right, let's say I'm at 60 degrees. The most amount of my, you better not, stop. The most amount of solute here, it's potassium nitrate. Oops. That's not that relevant for us. The most potassium nitrate you could dissolve is maybe like 120 grams, it looks like. Okay. Everything else would not dissolve, right? So that is how you can read this graph. One interesting thing to think about is when you cool a solution down, the solubility decreases. Because the solubility decreases, less solute is able to dissolve. All right, so we're going to figure out what's going to happen if we have a saturated solution that is cooled down. Let's put it on our graph, okay? I'm actually going to go back a slide because that graph was bigger, okay? Let's say we have a saturated solution at 100 degrees, meaning it is at its saturation point. It's at that line. That is 250 grams it would have dissolved. 250 grams. Okay. We are going to cool our solution down. And let's say we cool it down now to 80 degrees. Well, if we look, the saturation point at 80 degrees is around maybe 160 grams. Okay. So we have a saturated solution at 100 degrees. It contains 250 grams of dissolved solute. We cool it down to 80 degrees where the new limit is 160. Okay? New saturation point, new limit is 160. What will happen is, let me get a new color for my arrow. As our solution cools, it will follow this solubility curve, okay? It will follow this curve and it will obey its new limit, meaning now at 80 degrees, it would be a saturated solution with 160 grams. You may be thinking, wait, 10 seconds ago it had 250 grams. Where did all of those go? Well, because it now is a saturated solution with fewer, all of these extra grams that it had are going to what is known as precipitate out. What precipitate out means really means that it will become undissolved. All right, so let me write this over here. All of those extra grams are going to come undissolved because at our new temperature, the new limit is 160 grams. So all those extra grams we had are going to come out of the solution. They will become undissolved because they are over our new limit. We are going to watch a video of this happening that hopefully will give you a better idea. But for now, does anyone have questions about this?
No.
Alrighty, so we're gonna go to this video now. I think it's a cool video. What is going to happen in this video is in this test tube, okay, let me draw because you gotta know where to look. In this test tube here, they had a saturated solution at a high temperature. The beaker, which is this big thing all around, this has cool water in it. So the test tube is being cooled down when it is in the beaker. Because it is being cooled down, that means its solubility is decreasing. It can contain less dissolved material. So you can already see stuff has started to accumulate at the bottom. If you look around the center area of the test tube, you'll see stuff becoming undissolved. It's really, I think it's pretty, it kind of looks like snow is falling down. So just watch the center area. You can see, like, you can kind of see a flake already there, a little flake there, a little flake there. All right, it looks like snow. Ooh, now it looks like a face. Okay, it looks like snow coming down. Let me clear this, and here we go. Okay, so does anybody see just like a little bit of movement in the center? It looks like a downward movement. That is the solute becoming undissolved. All right, do we need to watch it again? Let's see. One last time. All right, that was the solute becoming undissolved when we got to a lower temperature. Does anybody have any questions about that? Any questions about that?
No.
Okay, so then we have one last thing to learn about today, which is as much as you want to try and make rules in chemistry, there's always exceptions. So sometimes the following can happen. We have our saturated solution at 100 degrees, 250 grams, just like we described, right? Option 1, which we just talked about, is when things cool, they cool down, they follow the solubility curve and become a new, they become a saturated solution at their new temperature, and all the extra grams get kicked out, okay? Blech, kick out all the extra grams that it had. Sometimes though, if things are allowed to cool in a very still and steady way, sometimes what will happen is they will cool down, and no matter what their new temperature is, they will keep all of their grams dissolved, okay? So even if it's at a new temperature, it will say, you know what, I'm keeping all of these grams that I had dissolved. That means at this new temperature, like at 40 degrees here, the saturation point, the limit, is all the way down here. It is way above that limit. Okay, it is so far above the saturation point. This is what we call super saturated. Super saturated. Super, a prefix not like superhero, a prefix meaning above or over. Okay, we are super saturated because we are above, we are over our saturation point. We are over the saturation point. And I want to make it clear, you can't just take a cup and keep stirring and stirring and stirring and think you're going to get solute above your saturation point. It's not going to happen. The limit exists for a reason. That's the limit. The only way you can get above a saturation point is what we just discussed. When you have a saturated solution and it cools down, and when it cools down, all of the solute stays dissolved. That is the only way to get a supersaturated solution. Anybody have questions about this? We're gonna watch a video where the woman explains it again. No questions? Okay, let's go to our video. Here's the second half.
One more term. Let's look carefully at what supersaturation really means. Let's say that I have a solution that's saturated at 10 degrees Celsius. I've got all the solute in there that the solution can possibly dissolve. It can't take another molecule. Well, what if I heat the solution to 30 degrees Celsius? And now it's got a larger capacity for dissolving solute. So I add some solute. I add enough solute to make this solution a saturated solution at 30 degrees Celsius. This solution at 30 degrees Celsius that's saturated has more solute in it than it did at 10 degrees. Okay, so far so good, 2 saturated solutions. Where does the supersaturation come in? If I can cool that solution from 30 degrees back down to 10 degrees and no solute precipitates out, then I have a supersaturated solution. So again, if I can take that saturated solution, raise it to a higher temperature, add more solute, make it saturated again, but with a higher amount of solute, and then cool it back to its original temperature without any solute precipitating out, we now, ta-da, have a supersaturated solution. If solute precipitates out when you cool the solution back down, it is not supersaturated. It's just a saturated solution with some chunks on the bottom. So if we go through that scenario again, and we take our saturated solution at 10, heat it to 30 and add more solute, and then cool it back down to 10, but in this case, the solute precipitates out, we do not have a supersaturated solution. We just have a plain old, boring, saturated solution with some chunks. I hope that helped you understand unsaturated, saturated, and supersaturated solutions. If not, email with questions. Have a good night.
Alrighty, that is the end of that video. How do I exit out of this? Hello? Exit. Hello? Keep pressing exit and nothing's happening. Oh, there we go. All right. Anybody have questions about that? Anybody have questions about that? Okay. All right, what I'm going to show you then is just a cool video about super saturated solutions. Going back, we know that super saturated solutions, whatever temperature they are way above the saturation point for that temperature, okay? They have way more grams than they should be allowed to have. As a result, they are very fragile, okay? You have to let it cool very gently and slowly. Otherwise, you're going to disturb everything that was dissolved in there, and it's all going to come crashing out, okay? You can even tap it. You can add a little sprinkle more. Anything like that is going to disturb it and mess up the solution. So that's what we're going to watch a video of. This is not the one I wanted. Back. Okay. So what you will see here is, this person has a super saturated solution, okay? We can tell just from looking at it. Come on, stupid thing, load, please. All right, we can tell just from looking at it, it is clear. Let's pause, okay? It is clear, everything is dissolved. It's slightly cloudy-ish, but there's nothing at the bottom. Everything is dissolved in this flask. So it is super saturated, meaning it has way more grams of solute dissolved than the saturation point. I'm guessing now the new saturation point would be whatever it is for room temperature, okay? Whatever temperature it is. They are going to disrupt this by adding in, he's going to add in a tiny, tiny pinch of extra solute. When he does that, it'll disrupt, and everything that was dissolved above the saturation point will become undissolved. It will precipitate out. Here we go. So he just added it in, I think. Yes. And there we go. Okay, he disturbed it, and so everything just precipitated out. Right? So what we're left with here is now a supersaturated solution a saturated solution at the new temperature. And all of this white solid at the bottom was what was dissolved that has now precipitated out. Let's watch it again. I think it's super cool. Okay, and so just like that, the solution has precipitated out all of that solute. Cool thing is, he'll show you, he's about to pick it up, tilt it to the side. And you can see all of that white solid, it really has come out of the solution. It's not in the liquid anymore. It is stuck. It is a solid at the bottom. So it really has become undissolved, come out of the solution, which I think is super cool. All right, we'll watch one more quick video of this. Same exact thing. This time, the way it precipitates out, it kind of looks, it does it in a pattern. So you'll see he's about to poke it. Why can't I make this full screen? Maybe because it's HD, I don't know. It's about to poke it with a little bit of the solute. There we go. Now I can make it full screen. All right, so again, that's pretty cool. Super saturated, and now it is adjusting. Okay, questions about this? Is that a no for questions about this? All right, last thing you need to know then for today is about our assignment. It is called PhET molarity inquiry, okay? In the PhET molarity inquiry, what you are going to do is all of this is using this link here. You can also just Google PhET molarity. It will be the first thing that comes up. You can do it on a phone or a computer, so it should be fine. Part 1, you are doing a very basic molarity calculation. You are just doing molarity is equal to moles divided by liters. That's it. Molarity is equal to moles divided by liters. I've given you moles and I've given you liters. So what you can do though, what is cool about this is you can go to the simulation. Let me reset it. And you can adjust your moles and your liters to double check your work. The important thing you need to know is to click this button that says solution values, right? You've got to click that, otherwise you won't have numbers. So there you go. You can adjust your moles, you can adjust your liters, and then be like, oh yeah, that is the molarity that I calculated, okay? Part 2 is the main part. What you are doing in part 2 is it's a list of the different solutes, and you have to say if it is saturated or unsaturated at 1 molar. 1 molar is the important part. So 1 molar, you've got to say, is it saturated or unsaturated? So how can you tell? That is a great question. Let's reset it. If you press the reset button, it will instantly go back to 1 molar for you. Change the solute down here, right? So we can tell if it is saturated or unsaturated based off of our definitions of those and our idea of a saturation point, okay? If we can add more solute and it dissolves, then it must have been unsaturated, right? Because if we add more solute and it dissolves, it can't be at the saturation point. It's got to be below the saturation point, therefore it'd be unsaturated. So we can look at copper sulfate. It's 1 molar now. You can increase your amount of moles a little bit. If you can increase your amount of moles and everything stays dissolved, it must be unsaturated. Here we go. Let's increase it. All right, I just increased my amount of moles. Everything is still dissolved. Therefore, at 1 molar, it was unsaturated. It is easy to tell what saturation looks like because, just watch. It tells you saturated, and then any more you add starts accumulating down here at the bottom. Okay? So it is easy to tell once you hit that saturation point. Part 3, you are just writing what is the molarity of the saturation point. Meaning you go to the saturation point as close as you can get to there. And then you can just write down, well, what is the molarity here? Okay. And that is really all you have to know for this assignment. It is due at 11:59 p.m. on Sunday. So you have lots of time for that.